So I'm going to share the program educational objective for your course. Okay. So for chemical diploma in chemical engineering. Okay. So you have 2 PEO, which is program educational objective that you need to know. Okay. So the first one is that after you finish your diploma in 3 years, okay, we hope that you're going to be an assistant engineer or maybe a graduate who are committed to sustainable development agenda and engage in social responsibilities in the community. Okay, so that is your program educational objective. So your objective after you graduated in 3 years, okay, so you are going to be a person, a graduate, or at least assistant engineer who are committed to sustainable development agenda and engage in social responsibility in the community. Okay, so we are looking at your involvement in any sustainable development activities in any organization. So if you work in a company, you should be involved in that particular sustainable development. Okay, so at the same time, if you're working, okay, the objective is to look at your involvement in any social or welfare activities in the community. Okay, so that is the first program educational objective for this course, for this program, diploma in chemical engineering. Okay, and then the second program educational objective is assistant engineers who are competent and progress in their career in chemical engineering or in any related industry. So we are looking at after you graduate in 3 years. Okay, so we are looking at least 10% of you working in any related industries. Okay, so as you know, when you have your diploma, okay, you can use your diploma in any related area or maybe unrelated area. It doesn't matter as long as the requirement is for you to have diploma. Okay, all right. So that is your program educational objective. Okay, so where you have to achieve this when you finish your diploma in 3 years. Okay, all right. Next is about this program. Okay, program outcomes. Okay, there are 12 program outcomes that you have to achieve, okay, in this 6th semester in your study. Okay, the first one is program outcomes 1, which is PO1. So this PO1 is apply knowledge of mathematics, science, engineering fundamentals, and engineering specialization to apply process and methodologies to wide practical procedures and practice. So bear in your mind, okay, when you attend your courses, okay, so you should reach or achieve these particular outcomes. Okay, so for this course, okay, we have PO3, PO4, and PO10. Okay, so just go through PO2, maybe your lecturer will explain later in other courses. PO2 is to identify and analyze well-defined chemical engineering problems in handling engineering equipment by using appropriate analytical methods and tools. Okay. All right. The third one is to design solution for well-defined chemical engineering technical problems. No, where is it? Okay, Telaja. To design solution for well-defined chemical engineering technical problems, components or process to meet specified needs with appropriate consideration for public health and safety, cultural, societal, and environmental consideration. So this PO3, you're going to achieve when you do your CO1 later. Okay, CO1, right? And then you have PO4, which is also in this course, okay, which is to conduct investigation related to chemical engineering of well-defined problem, locate and search relevant codes and catalogs, conduct standard tests and measurement. So far, for this course, CHE 249, your outcomes or program outcomes are PO3 and PO4. Okay, so let me proceed to the PO5, because the next PO that you need to know is PO10 for this course. Okay, PO5, identify and apply appropriate techniques, resources, modern engineering, and IT tools to handle well-defined chemical engineering problems with awareness of limitations. Okay, PO6, demonstrate awareness of societal, health, safety, legal, and cultural issues and the consequent responsibilities relevant to engineering technologies, practice, and solutions to well-defined chemical engineering problems. Okay, PO7, understand and evaluate the sustainability and impact of engineering technician work in the solution of well-defined chemical engineering problems in societal and environmental contexts. PO8, understand and commit to professional ethics and responsibilities and norms of technician practice. Okay, next, PO9, apply knowledge of mathematics, science, engineering fundamentals, and engineering specialization to apply processes and methodologies to wide practical procedures and practices. Okay, this is PO10, which is your program outcomes for CHE 249. Identify and analyze well-defined chemical engineering problems in handling engineering equipments by using appropriate analytical methods and tools. Okay, so this part, okay, so you need to achieve for this course. Okay, PO11, to design solutions for well-defined chemical engineering technical problems, components, or processes to meet specified needs with appropriate consideration for public health and safety, cultural, societal, and environmental consideration. And the last program outcomes is conduct investigations related to chemical engineering of well-defined problems, locate and search relevant codes and catalogs, conduct standard tests and measurement. So all these program outcomes will be explained by your own lecturer for the specific courses that you are taking this semester. Okay, so make sure that you achieve these outcomes for every courses that's involved, okay, so that you understand what are the expectations by the faculty to you, okay, and then what are the expectations from the industry to you, and so on. Okay, so when this course will be accredited by ETAC, they will come this semester and they will interview some of you. If you are selected, they just pick in random and they will ask you questions regarding to the program outcomes, regarding to the the program educational objective. You should be able to at least know something regarding to the program educational objective and then program outcomes. Okay, there are two things that you need to know. When they come, they will ask you questions regarding to this. Okay, are you alert on these program educational objectives or not? Are you alert on the program outcomes or not? So what are the program outcomes that you have achieved for your course? Okay, what are you expected to achieve after you graduated from this course, from this program? Okay, so you should be able to answer these particular questions, not for the faculty, but for yourself, because when they accredit this program, you will benefit from this accreditation, not the faculty only. Okay, so they will give you the accreditation on the program so that your certificate, your diploma will be recognized out there in the industry, whether it is local or in the global. Okay, so make sure you know what you need to achieve for this course. Okay, all right, so let me continue on course outline. So do you have any question regarding to program outcomes and program educational objectives? You can ask me now while I'm changing the slide. Any questions? All right. So I'm going to share with you about, I'm going to explain about the course outline. Okay, so I'll give you the course outline later in the group. Okay, so make sure you have registered CHE 249. Okay, so this is the core subject, a very important subject because it's involved application and skills, right? And the lecture will be shared by me and Madam Zarina. Okay, so for these two chapters, okay, I'm going to be in charge on the math lecture. Okay, and then later Madam Zarina will take over. Okay, for the next two chapters. Okay, all right. So this description of this course. So this course involves the study of mass transfer. Okay, mass transfer. So I think that you're going to take, have you taken your heat transfer subject? Or are you taking that this semester?
We take this semester.
This semester, okay. So you're going to learn mass transfer in this subject, and you're going to learn heat transfer in that particular subject lah. Okay. So this mass transfer, the study of mass transfer, as well as performance of equipment for solvent extraction, gas absorption, and distillation. A very simple description. So we are talking about mass transfer, and that's involved equipment for solvent extraction, gas absorption, and distillation. Okay, so the basic theory involved in this course is mass transfer. Okay, all right. So the following are your course outcomes. Okay, they are related to your program outcomes. They are related to your program outcomes. The first outcomes is for you to analyze problems related to mass transfer in separation processes. Okay, so that is related to program outcomes number 3. Okay, program outcomes number 3. Okay, and then the second outcomes for this course is to justify the concept and application of mass transfer in separation process. So these two outcomes, okay, will be tested in your quiz and your exam. Okay, your quiz and your exam. The first part is for you to analyze problems related to mass transfer in separation process. So that's involved cognitive number 1 till cognitive number 4. Okay, so this will be covered in your quiz. Course outcomes number 2 will be covered in your exam. Okay, in your exam, which is to justify the concept, not only solve the problem, but you need to justify your answer. Okay, your answer to the questions. All right. Okay, course outcomes number 3 is to respond to the experimental and simulation outcomes of separation process experiment. Okay, separation process experiments. So these outcomes should be achieved during your practical doing the experiment. Okay, so you should achieve this during the experiment session. Okay, so that's involved the psychomotor skills. All right, so you will be observed on the how you handle the equipment, how you start up the process, how you run the experiment, how you take your result from the experiment, and then how you analyze the result from the experiment. Okay, so this is very important. Okay, and then CO4, which is present the concept and application of mass transfer in the separation process. So this is effective number 2, where you need to do the presentation. Okay, presentation. Okay, all right. So in this course, you need to do your quiz, you need to do your exam, to do your experiment. The experiment is the normal experiment where you have to go to the lab and do the 4 experiment, and then also involved in simulation process. Okay, simulation where you're going to take your You're going to take your result that you have for your experiment and simulate that using the software that will be provided for you in the lab. Okay, in the lab where you have to use Aspen plus simulation software. Okay, so these are the things that you need to do other than presentation towards the end of the semester. Okay, all right. Okay, so these are your lesson plan. Okay, first chapter, mass transfer. Okay, we have about 6 subtopics. Okay, 6 subtopics to achieve in 2 weeks. To achieve in 2 weeks, all right. So you should be able to at least know the theory behind the process, which is the basic theory, which is called mass transfer theory. Okay, and we have to finish this in 2 weeks. Okay, so today you have your first lecture. Okay, later next week you have another lecture. Okay, finish already first chapter. Okay, second chapter, which is distillation. Okay, so for this chapter, we're going to take about 4 weeks to finish. Okay, 4 weeks to finish. All right. So for this chapter, you're going to learn about batch distillation, continuous distillation, okay, and maybe multi-component distillation. Okay, so this involves more on the understanding the theory together with the calculation. Okay, but for the mass transfer for chapter number 1, you need to understand the theory first and do the calculation. You have a little bit of calculation, but for second chapter distillation, you're going to use whatever that you have learned in chapter 1, okay, which is the theory, to understand what happened in your chapter 2. Okay, and we have a specific calculation for this particular chapter. Okay, next, okay, liquid extraction will be handled by Madam Zarina. Okay, so you're going to learn about liquid extraction, where you have to know on the calculation for the single stage and multiple stage. Okay, multiple stages. So you're going to spend about 3 weeks for these particular topics. Okay, and followed by gas absorption. Okay, where you need to know about 2 types of gas absorption, which is bobbing pack tower and tray tower. Okay, so we have pack tower and tray tower. Okay, and the last topic is the special topics, which involve other separation processes. So for these other separation processes, you need to do survey, you need to search for the information and do the presentation. Okay, so these presentations, the topics must involve other topics other than what you have learned in this particular course. Okay, all right. So by looking at that, everything that you have, okay, so these are your assessment. Okay, your assessment involve quiz, group presentation, practical and final assessment, okay, which is your exam. Okay, so your quiz 10%, your group presentation 20%, your practical and or lab 30%, and your final assessment, which is 40%. So quiz CO1, final assessment CO2, okay, practical CO3, and presentation CO4. Okay, all right. So these are your grades. Okay, so if you aim to get A, so you have to achieve this particular marks. All right. Okay, and references. Okay, you can buy a book which is called Transport, Process and Separation Process Principles, okay, by Ken Coplis, or you can use McCabe, Smith, and Harriet, Unit Operations of Chemical Engineering, Coulson Richardson, and Trebot, Mass Transfer Operation. So you can have these books from the library that you, I think library in Bukit Besi also you have this particular book, or you can look for the ebook from the library. Okay, so I'll give you some, but it doesn't mean that you don't have to read other books. Okay, so the main reference book is called Transport, Processes and Separation Process Principle, Ken Coplis. Okay, all right. So normally we ask students to buy this book. Okay, if you can buy this book, it's okay. It's good, very good to buy this book, because if you plan to study further in your degree, okay, you might need this book also. Okay, so majority of the books that you have during diploma will be used during your degree. Okay, all right. Attendance. Okay, attendance is compulsory, so you have to take your attendance in UFuture, and then at the same time you need to do the to participate in the discussion during the tutorial, during the math lecture, and so on. Okay, so if you fail to attend, 30%. Okay, warning letter will be given to you. Maybe you'll be penalized with some, I don't know. So you know the regulations. Okay, so make sure that you attend the class. Okay, same thing if you're doing your work in a group work, make sure you take parts in every discussion, in the written parts, okay, and so on lah. Okay, test, no makeup test unless you have medical excuses. Okay, so that's also involve quiz. And then no cheating. Make sure you don't cheat, because most of your submission will undergo certain certain tests, okay, where you have to check the plagiarism rates or similarity rates. Okay, so if you cheat, you know lah what happened, kan? Okay, all right. So I think that's all regarding to the course outline. So any question regarding to the assessment? So chapter 1 is about mass transfer. Okay. So introduction to mass transfer. So one thing that you have to know about mass transfer is about the transfer of matters, okay, or species. Okay. So we only focus on matters or species or components. You can call it components. Okay. So the transfer of a species or components from high concentration to lower concentration. So this is the theory on mass transfer. So how how species, how components can be transferred. So they can be transferred due to concentration difference. Okay, concentration difference. Okay, so they should be transferred due to concentration gradient. Sometimes they call it gradient, sometimes they call it difference. Okay, but one thing that you have to know, the transfer must take place from high concentration to lower concentration. Okay, so if you were to define what is mass transfer, you should define as this mass transfer as species or components or matters, okay, that is transferred from one place to another place using due to difference in concentration or due to concentration gradient or from high concentration to lower concentration. Okay, all right. So are you clear with that definition?
Yes, Miss Ita.
Okay, good. All right. Next is to look at the how it's happened. Okay, how it's happened. Okay. So if you look at the diagram here, okay, the image or the photo here, so we are talking about the transfer of molecules or water molecules. Okay, the process is called evaporation. Okay, so evaporation is also called the name for mass transfer. Okay, one of the process involved in mass transfer is called evaporation. Okay, so we are talking about the transfer of components. For let's say we are talking about water. Okay, water components transfer from bulk of water to the environment. Okay, to the environment. Why does this occur? You need to understand, because when you talk about water in a bulk of water components in a bulk of water, the concentration of water or water components in this particular bulk of water, they have higher concentration here. Okay, in the environment, open air, the concentration of water is less. Okay, so that now you can call concentration of water in the air, they have lower concentration compared to the concentration of water in the bulk of water. Okay, and maybe you can say, okay, this is water in the river, this is open air. So the water in the river, okay, in the water river, okay, in the river water, they have higher concentration. Here you have lower concentration. So that's why the movement of the water components, it must be from high concentration to lower concentration. Okay. All right. Now we have another example. This is just a simple example for you to understand what is mass transfer. Okay. All right. Now look at this. So you have two components or two matters or two species. Okay. So you have sugar and you have water. Okay. The next image. You have sugar and water. You have two things here. Okay. Two components of species. Right. So when you pour sugar in a cup of water, okay, in a cup of water, so your sugar must be in the solid form. Okay. All right. So after a few minutes, okay, after a few minutes, the sugar turns into sugar solutions. Okay, sugar solutions in the water. So it shows that diffusion or mass transfer takes place where you have, okay, you have to look at this one by one. Look at this one by one. So when you talk about sugar, you talk about sugar move from high concentration to lower concentration. Okay, so you talk about one component to another components. Okay, so refer to sugar only. So this is how you will define the mass transfer if you look at sugar. Okay, sugar move from high concentration to lower concentration. Okay, a bulk of sugar, you have high concentration of sugar. In the water, you have lower concentration of sugar. So you talk about sugar, sugar, high concentration, sugar, lower concentration. So that is how you mention about the mass transfer of a component. Okay, right? So higher concentration of sugar, lower concentration of sugar. So that's why sugar move from high concentration to lower concentration. So that's why you achieve to get sugar solution. Okay, sugar solution. All right. So you have other example also when you talk about absorption and desorption. Okay. So I only want to explain to you the basic, the simple example for you to understand what is mass transfer. If you were to define mass transfer, make sure the keyword are stated in your explanation. Okay. The keyword is the motion of a species. Okay. A motion or a movement of a matter, okay, from high concentration to lower concentration. So this high concentration to lower concentration can also be defined as concentration gradient. Okay, all right. Next, okay, so when you talk about concentration gradient, okay, when you talk about mass transfer, you cannot run away from the word diffusion. Okay, so the best word to use here other than movement is called diffusion. Okay, all right, so let's look on what we have here. Okay, so this is by looking at molecules. Okay, molecules, all right. So when we talk about molecules, okay, take a look at this. The spear shape here, these are called the molecules of dye. Okay, dye molecules. Okay, so dye, and then you have water. Okay, so the concentration of dye here in this partition, the concentration is higher compared to the concentration of dye in the water. Okay, so based on the theory, so you have to look at the motion or the movement or the transfer of dye from this partition to the next partition. Okay, right? So the dye, okay, the molecules of dye will diffuse in water due to the concentration gradient. Okay, why due to concentration gradient? Because more explanation can be said here. You have lower concentration of dye in water. Okay, remember again, I mentioned to you, you talk about one components only. Don't talk both of them. Okay, so focus on one components first. Okay, high concentration of dye diffuse to low concentration of dye in water. Okay, so you can achieve diffusion from this partition to the next partition. Partition A to partition B, or partition number 1 to partition number 2. Okay, so you can achieve now, all right, you can achieve the diffusion. So diffusion will take place. Okay, so this is initial condition, this is the middle situation condition, and this is the final condition. Okay, so diffusion will occur from higher concentration to lower concentration until both partition will have the same concentration of dye. Okay, so you have, if you have the same concentration in partition number 1 and the same concentration of dye in partition number 2, therefore you can say that equilibrium has achieved. Okay, equilibrium has achieved. Is there any diffusion occur? Still, diffusion still occur. Diffusion will not stop. Okay, so again, so this is a theory. That's why I need to explain to you so that you can understand. At the same time, you should know how to write in words. Okay, write in words. Okay, so the words that you write, okay, the sentences that you write, okay, will reflect to the diagram when you draw the diagram. So this is what we need from you. Okay, so you might be asked about explain mass transfer. Okay, give example of mass transfer. Okay, describe mass transfer, and then describe mass transfer using a diagram. Okay, so these are the types of questions will be asked to you. Okay, all right. So if you have any question, you can ask me. You can interrupt me, because I cannot see you when I share the screen. So you just interrupt me. Okay, just call my name and then ask questions if you don't understand. So please do that. Okay, all right. So using the diagram, you can explain mass transfer takes place, okay, between molecules of dyes and water. Molecules of dye and water. Okay. So how molecules of dyes transfer from one partition to another partition, because you have a membrane cross section here. Okay. So we can say that you have the concentration of dye in partition number 1 is higher compared to the concentration of water in the concentration of dye in the second partition. Therefore, diffusion takes place due to the concentration gradients of the dyes molecules. Okay, all right. So the dyes move from higher concentration to lower concentration. Okay, and this happens, okay, this will occur continuously until the equilibrium condition is achieved. Okay, where, okay, when equilibrium achieved, the concentration of dye in the first partition, okay, will be the same as the concentration of dye in the second partition. Okay, so the motion will occur backward and forward, but the concentration of both partitions still the same. Okay, still the same. Okay, all right. So that is based on one components of dye in water. So let's say you have diffusion of two solutes. Okay, another diagram below here. Okay, same thing. You're going to recognize partition number 1, partition number 2. So, but when you discuss one by one. Okay, when you discuss about the dyes or the yellow dyes, okay, the yellow dyes or the yellow components, okay, you say that the yellow components diffuse from partition number 1 to partition number 2 due to the concentration gradient. Okay, all right. So when you go to the second diagram, diffusion occurs due to the concentration gradient. Higher concentration in partition number 1 for component, yellow component, and lower concentration in the second partition for yellow components. And diffusion occur until, okay, until they reach equilibrium where the concentration, okay, remain the same for both partitions. Then we discuss about the purple components. Okay, the purple components here, okay, will diffuse to the left. Okay, will diffuse to the left. Why? Because the concentration of purple component is higher in the second partition compared to the first partition. Therefore, diffusion occurs from partition number 2 to partition number 1. So they move that way. So they will move, okay, they will move due to the diffusion until they reach equilibrium, where the motion will be to the left and to the right. Okay, so you can see here, when equilibrium occurs, okay, you have concentration for both sides. For each components will be the same. Okay, so but you are referring to only one components. Okay. All right. Okay. So these are when you talk about two solutes between A and B or B and A. Okay, all right. So when they reach equilibrium, so you can see that the counter diffusion will occur. Counter diffusion will occur. All right. So from the beginning, only for let's say this one, they move to the right. Okay, to the right only. Okay, but later after they reach equilibrium, they move to the right and to the left. Okay, move to the right and to the left. Okay, so this is called counter diffusion. Okay, so same thing for the diffusions of two solutes. Okay. Okay. All right. So please imagine, try to remember on the how you describe the motion, how you describe the movement, and then how you describe the concentration. And then the last one is how you describe the diffusion process. Okay. There are three diagrams that you need to figure out before. Okay, before the diffusion occur, you can see the situation. Okay, during the diffusion, you can see how the process takes place. And then towards the end, you can see when it reaches equilibrium. Okay, all right. So now is the law. Okay, so we have covered what? First, only the general information on mass transfer. General information on mass transfer. You have to understand what is mass transfer. We are talking about movement of mass only. Okay, movement of mass. Okay, why does it occur? So you have a definition, lower concentration to a higher concentration to lower concentration. Okay, and then you are introduced with the term of diffusion. Okay, diffusion of a single material, single component, diffusion of two components. Okay, all right. So you start with the initial condition during initial conditions. Okay, before it's occur, you have during the process, and then you have the equilibrium condition. Okay, now is the law. Okay, so when you have the law, you need to follow the law to do the calculation. So in the first two slides, they are for the explanation. For now is the law that you have to follow. The law is called Fick's law. You have to use this law to describe how strong is the diffusion is. Okay. So when you want to describe how strong, so you need to calculate. Okay, you need to do the calculation. So to do the calculation is to know that number 2 is smaller than number 8. Okay, 7 is bigger than 8. So 7 is bigger than 5. Something like that. So you need to describe, because we need to know how strong is the one that you call strong. Okay, so you have to do the calculation. Okay, so you have to use Fick's law. Okay, so just use Fick's law, and the Fick's law formula is given by this formula lah. Okay, this formula. Okay, and how do you calculate the strength? You calculate the strength is by calculating the flux. Flux, The flux is for you to know the value. To know the value. Okay, flux. So we are talking about to calculate the molar flux of diffusion. Okay, molar flux of diffusion of component A in the Z direction. Component A in the Z direction. Like you have the sugar in the Z direction. Okay, so diffusion is a vector, actually. Diffusion is a vector. So that's why you have direction when you calculate the flux. So direction can be linear direction, can be circular direction. There are many types of direction. Okay, you have vertical direction, you have horizontal direction, you have inclined direction, you have circular direction. So molar flux is also have directions. So for molar flux, we have a linear direction, whether you are talking about left, right, or north and south lah, or something like that. Okay, top, bottom, something like that. Okay, so it's given by negative C, which is the total concentration. Okay, multiply with the molecular diffusivity of A and B. Okay, and multiply with the small difference between X, which is mole fraction of A, with the small change in the Z direction. Okay, small change in the mole fraction of A, component A, with a small change of the distance Z, which is your direction. Okay, so this Fick's law can be simplified in this form. Okay, so your molar flux is given by negative diffusivity of A and B, multiply with the difference in concentration of component A and small difference of Z direction or distance. Okay, so you can look here, the unit, the J or the flux unit is kilogram mole per second per meter squared. Meter squared is the area. Meter squared is the area. S is the time. Okay. And then you have Z here is the distance of diffusion. From position 1 to position 2, what is the distance? Okay, so you just measure the distance from location 1 to location number 2, or position 1 to position 2. Okay, so that's involved only 2 location only. Okay, all right, next. Okay, so we are playing with the formula actually. Okay, I hope that you don't fall asleep lah. Kan? Okay, so this is your homework. Homework ya, bagi dulu homework. Okay, Fick's law for steady state and diffusion of a binary mixture of A and B. Okay, just now we have purple and yellow dyes. Okay, purple compound and yellow compound. So you have A and B, right? So that is called binary mixture. Okay, binary mixture of A and B. Okay, all right. So formula. Okay, the molar flux in terms of mole fraction. This is the second one, is the molar flux in terms of concentration. Okay, there are two things here. This is mole fraction, this is concentration. Okay, so because you have derivative here, you learn your mathematics already, right? Okay, belajar tak ni? When did, in which semester that you learn derivative and integration?
Semester 2, Miss.
Semester 2. Is it? Is it semester 2?
Yes.
1.
Yeah. Semester 1. When did you learn your calculus?
Semester 2.
Semester 2. Okay. So, when you have derivative symbol, how to get rid of this derivative symbol? You get rid of this derivative symbol by introducing integration symbol. Am I correct?
Yes, Miss Ita.
Yes, okay. So the only difference is that, okay, for mathematics lecturer, they don't like you to put integration, divide by integration. Okay, but actually you just shift your dz over here. Okay, you just shift your dz, bring it to the left, and then do integration for both sides. Okay, just introduce integration for both sides. Okay, so when you have integration, you have to have upper limits and lower limits. Okay, you have to remember that because you have learned your calculus. Calculus is very important for you, okay, to understand further, to understand more on what you have learned for the formula. Okay, you need to use integration in this case. Okay, so you have lower limits and upper limits. Lower limits should be written at the bottom of the integration. Okay, integration symbol, and then upper limits on the top of the integration symbol. Okay, so the lower limits represent the concentration of A in position at position number 1. This one at position number 2. Okay, so that's why you have CA1 and CA2. Okay, now same thing for the distance. You have distance at A, distance of A at position 1, distance of A at position number 2. Okay, so if you consider position number 1, the distance is 0 meter. Therefore, at position number 2, you have achieved a certain amount of distance. Okay, all right. So you can have that. Okay, therefore, now you have this particular symbol. Okay, all right. So you have lower limits, upper limits minus lower limits. Okay, all right. So this one also, you have upper limits minus lower limits. Okay, and you can also get rid of this negative symbol by arranging again your CA1 and CA2. So you get rid of this negative. Now you have CA1 minus CA2. Okay, so you get rid of this negative symbol. All right. Okay, all right. So this is, okay, by looking at this formula, fixed law formula for binary mixture of A and B, okay, it is very clear that, okay, you can see you are dealing with the concentration in terms of concentration. So the molar flux molar flux that you have here must be in concentration gradient. All right. But if you were to write in a partial pressure, in the terms of partial pressure, you have to change this formula into this formula. Okay. All right. Why? Why do you need to use different formula to do the calculation? Okay. For the molar flux, in terms of concentration, normally it is used to calculate the molar flux for liquid. Okay, for liquid. All right. So if you were to calculate the molar flux for the gas, it must be, the formula that you use must be in partial pressure terms. Okay, in terms of partial pressure. Okay, in terms of partial pressure. Okay, so now you have two terms, which is in terms of concentration and in terms of partial pressure. How do you convert from a concentration to partial pressure? So please use what is given here to manipulate the formula until you get this formula. That's your work, your homework. Okay, so this is your homework. Because what? Why do you have to do this? Because during the exam, during the test, you might want to do that. The question might ask you to do that. Okay, they ask you to derive from this equation, okay, from this equation until you get this equation. Okay, they might ask you to derive starting from the molar flux in terms of mole fraction to molar flux in terms of partial pressure. Okay, so again, take notes. Take notes. When you deal with liquid, you use molar flux in terms of concentration. When you are dealing with gas, you use molar flux in terms of partial pressure. Very simple. Okay, very simple. Okay, all right. So this is your exercises that you need to do. So this is also your homework. So try to do this homework So you are dealing with, what is this? Gas, eh? So you are dealing with gas. Therefore, what do you need to use? You need to use molar flux in terms of partial pressure to solve this problem. Okay, molecular diffusion in gases. Gases. Okay, so repeat balik ya. Apa kita belajar tadi? Okay, pertama, general information on mass transfer. Second, definition of mass transfer in terms of diffusion. Okay. The third, to calculate the strength of the diffusion. To calculate the strength of diffusion is to calculate the molar flux. Formula, what formula can you use? You use Fick's law formula. Fick's law number 1. Okay. Ingat macam tu. So, bila you ingat, senanglah nak belajar. Okay. Now, we go to the diffusion in gas, which is called equimolar counter diffusion. Equimolar counter diffusion. And we have described about this already in the diagram. Okay, we have described this. Okay, so the only thing that we have discussed, we use different components. Now, let's assume that we have two gases. Okay, you have gas number 1, gas A and gas B. You want to mix them. Okay, both are located at different container. Both are located at different container or different partition. And they are allowed to diffuse to another partition, from another partition to another to other partition. Dia macam tu. Okay, they are allowed to mix. Okay, so you're going to open the valve. Okay, so in the industry, what happens is that the partition that you have here, in between here, may be the valve. Okay, so the partition that you have here, partition number 1, might be a tank. Tank number 1, this one tank number 2. They are connected in a pipe. Okay, they are connected in a pipe. And you have valve in between of the pipe. If you open the pipe, what happens? Okay, because gas, when you learn about kinetic of gas, the gas molecules move randomly. You can belajar physics. When you learn about physics, you learn about kinetics of molecules. They move randomly. They don't care about the direction. They just move randomly. Okay, all right. So it depends how fast they move. It depends on the temperature. It depends on the pressure. Kan? You learn about your physics already in SPM. Definitely you get A, kan? You score A in your SPM for physics. You are excellent student. So you have to understand what's going on. So don't assume that what you have learned before, you cannot use it here. The knowledge is always useful. That's why you have to know, you have to try your best to gain more knowledge. Read more, understand more, apply more. Okay? So that you can be a better person. All right. So go back to what we have. Now we have a formula which only involves gas, which is called equimolar counter diffusion. Okay. So you have tank number 1, tank number 2. Tank number 1, you have yellow molecules. Okay, gas, yellow gas. Tank number 2, you have purple gas. I have explained how does it work. How does this one works? Okay, so you should understand by now. Okay, so if you look for the yellow, you just discuss about yellow. If you want to talk about purple, you discuss about purple. Macam tu. Okay, so this is what happened when you want to calculate the yellow flux. So molar flux of yellow gas. So you mentioned about JA. If you want to mention about molar flux of purple, you mention about JB because they are separated using a pipe or a membrane. Okay, this is what happened. Lower concentration, you have higher concentration first for yellow here, but lower concentration of yellow in the location number 2 or tank number 2. Okay, so that's why diffusion of the yellow gas will go to the tank number 2. Okay, right? So until they reach equilibrium. But if you look for the purple, higher concentration of purple gas in tank number 2, lower concentration of purple gas in tank number 1. So that's why diffusion occurs from higher concentration to lower concentration. So you can see the purple will go there. Okay, then until they reach equilibrium where they move in both directions. Okay? So when they move in both directions, you can see that now at the beginning, you can see that they have reached equilibrium and counter diffusion occur. Okay, counter diffusion occur. So if you're looking for the speed, for the strength, okay, for the strength, all right. So these are the motion. The motion can also be described based on partial pressure. Okay, partial pressure. Okay, so if you talk about liquid, then you talk about concentration. But when you talk about gas, you talk about partial pressure. So let's say component A is the gas. So partial pressure A at location number 1 must be greater than partial pressure of A at location number 2. And then if you look for B, which is the purple, partial pressure at location number 2 for B is higher compared to the partial pressure of B at location number 1. So we are talking about difference in concentration gradient occur here. Okay, so by having that, when you talk about equimolar, equi means equal lah. Okay, equal, right? When you talk about equimolar counter diffusion, the formula that you can use for Fick's law is JA in the Z direction is equal to JB in the Z direction. Okay, because they move in opposite direction, therefore you're going to consider your axis or your direction is positive from left to right. Left to right is your positive direction. Remember, diffusion is a vector. Okay, right? So molar flux is also a vector, right? So that's why you have J and Z and you have negative here. Okay, the diffusion or the molar flux are the same for A and for B, but they move in different direction. Because you're dealing with A and B, so the diffusivity of DAB always equal to DBA. It doesn't matter because this is a constant. Okay, a constant or diffusivity value between component A and B is the same as diffusivity of component B and A. They are the same because they are constant. All right. So from this formula, you can reach the bottom formula. Okay. All right. Okay. If you have any question, please interrupt. Tak ada soalan, saya kira you pandai dah. Okay, so homework, please do example number 6 to 6.2.1. Okay, jawapan ada kat bawah. Okay, alright. So please do example number 1. Ni example number 2. Mana dia tadi? This one and this one. Okay. All right. So once we have done this, okay, submit to UFuture. I will give you the link for you to submit your work individually. Okay. If you don't submit, means that you do not participate in this session. Okay. So you can do it now because you have about 20 minutes or 10 minutes to do it. Okay. So I will continue this in the next lecture. Okay. So again, let me summarize. For molecular diffusion in gas, there are few categories that you need to know. One is called equimolar counter diffusion in gas. Okay, remember equimolar counter diffusion, first type. Second type is diffusion process with convection. This is second type. And the third type is diffusion through stagnant and non-diffusion B. Okay, so this is the third type. Okay, altogether for diffusion in gases, you have three types that you need to know. So please differentiate these three things, okay, these three types. Because when you answer question, you need to focus. Are you given equimolar counter diffusion question? Or are you given the diffusion with convection? Or are you given diffusion through stagnant non-diffusion B? And then once you know the types that you're dealing with, then you know what formula that you have to use. If you don't know the differences between them, then it is difficult for you to choose what formula to be used in your calculation. Okay, chapter number 6. Okay, let me share. So saya bagi tu bukan sesaja ya. Tolong ya. So please appreciate benda-benda extra information that is given to you. So you can use this reference for your understanding, for your exam, for your quiz, for your lab report. Okay, so please. Okay, so this is for, if you want to read, this is chapter number 6. Boleh, you can start with chapter number 6, which is Introduction to Mass Transfer and Diffusion. Okay, so up to so focus on 6.1, 6.2, and 6.3. Okay, so you can do your reading first. Okay, and then later in the next chapter, you're going to proceed on the vapor liquid equilibrium dulu. Here, chapter 11. So you have more time in these few weeks, early semester. Please read. Okay, vapor liquid separation. So this is for the distillation. So for distillation, we are referring to chapter 11. Okay, all right. So later you have many here actually. Okay, and the same thing for your presentation also. You can refer to this book and give some examples based on your understanding. Okay, and then back in your mind, you have to do the experiment. You have to do the 4 experiment. You're going to proceed with the experiment even though you have not learned about this topic. Okay, let me remind you that, okay, there are 4 experiments when you enter the lab. Okay, you'll be given the experiment based on your turn. Okay, it doesn't matter whether you have learned these topics or not for distillation, but still you have to do the experiment on your own by following the procedures. Okay, for liquid extraction, for gas absorption, which is about in week number 6, week 7, and so on. After that, okay, but you have to do so. In order for you to understand, you have to read your reference book. Okay, all right.